Hi everyone, Evgeny is back with you today, and this video is about AI agents. So we are going to look at the ways how to build your own thing. We are going to check different aspects of building AI agents. We'll be progressing from the simple things to the more and more complex topics, and we are using LangGraph as our building tool. So please join me in the first video of how to build your own AI agent. All right, so today we are talking about chains, and that's not specifically agents, but this is the first step which will help us to better understand how agents are working in the future. And as I told already, we are using LangGraph today because this is a really cool tool for constructing AI agents. And we'll see how it goes. So today's task is to start with something simple, like check how you can create simple graph, which looks like a bit of a chain. All right, and if we are talking about, or when we are talking about land graph, so we need to understand some basic words, and this is the classical kind of example of the graph from LangGraph. And here we are operating with nodes. So every single piece of functionality, uh, the name is node, and different nodes are connected between each other. So this transition kind of thing, it's called age. And also we do have a specific node for starting and for finishing our graph. And also, of course, we have a state. So this is just think about that. It has nothing to do with LLM at the moment. It's just a state machine where we have different states, we have different transitions. Some transitions can be conditionally, and you are passing states through the nodes via ages. So, and this is the core nature of what's happening in this graph thing. So again, we have nodes, we have ages, and we do have a state which is being passed through the whole graph, and we have start and end. And just let's go through all these concepts and see how it works with real thing, right? So normally, and this is Python, Monty Python thing, because, well, Python is number one thing when we are talking about LLMs. This somehow happens. Not that I'm a big fan of that, but this is the reality. And state, it's just a simple dictionary. So you can provide whatever you want across your diagram, across your nodes. And yeah, that's it practically. You have keys, you have values, you store some information related to your business process or workflow. And as an example, we can make it even more strict thing. So we can define state as this one. Let me run it. And it's just a dictionary with a single key state, which is a string, and it contains something. We don't care much about that right at the moment. And the next thing is a node. And well, how can I define a node? It's very simple. It's just a function in Python. So if you take a look here, I have 3 nodes already defined, kind of for this graph, 1, 2, 3. And every node takes a state, so it can logically react on the specific state, and it returns back also state. So the idea is that every node performs some work and returns the updated state, which is being passed to the next node, and so on and so forth. So here we have definition for 3 nodes, and well, let me also update that. All right. And next thing is ages. And well, for now, let's think about this as we have 2 types of ages. It's the simple one where it goes always from A to B, like, well, here we have this one from node 1 to node 2. But also we can define a conditional age which knows where to go next. And for doing that, again, surprise, surprise, we're using Python. It's not a Python function, how it's written here, but it's Python. So this is how it looks like. Again, we have a Python function. It takes state again, and based on something, it can decide where to go. So here, for example, we are taking some random value. So it's 50-50. And if it's the first part, it goes to node 2. If it's the second part, it goes to node 3. And this one doesn't do anything useful here, just for as an example, right? That in a normal way, we make our decisions based on internal state of the graph. So, but here it's very simple. We have the definition of, again, optional route, and it's half of the time you're going to node 2, half of the time you're going to node 3. Let's apply that as well. And well, I think we have all the smaller components, so we can try and construct a real graph in LangGraph Studio. So how it looks like, it's very simple. We have this state graph class, which we can start as a builder. We do have specific start and end nodes, and then we define it. It's very pretty simple, right? It's adding node. We're adding ages. Here we have the additional, the conditional age that we defined earlier, this 50-50%, remember? And practically that's it. We can compile the graph at the end, and we even can visualize it. So it's we can check that everything is fine. So let's do this. At the end of this snippet, what will be here, graph will be defined, and we will have a visualization of that. So let's run it. And see, here we are. We have a start node, we have an end node, we have node 1, and then a decision is taken. That's why you have these dotted arrows, and it can go to node 2 or to 3, and direct unconditional age from node 2 to end and from node 3 to end. And this is how it works. So let's try to invoke it, and we'll see some results probably. But let's first try to predict what's happening. So when I'm invoking a graph, I'm defining the state, and I'm just writing here hi there, and it goes to node 1, right? And node 1, we know that this was a method, a function, Python function. So it would print us node 1, and it would replace state with the current state plus this function tag, let's call it this way. And those are the same, right? So what happens then, based on random chance, it goes either here or there, and again, it will be printing, and it goes to the end. So let's give it a try. I'm running it, and see we have it was node 1, node 2, hi there, and we have the tag from the first node and the tag from the second node. And theoretically, if I run it several times, then sooner or later I will go to node 3 as well. It's always the first part. Oh, here we are. So here we have nodes 3, 1, 3, and 1, 3, and hi there. So this is the way how it works in LangGraph. This is practically the simplest graph you can create. So having that, we are ready to make our feet wet with LLMs and artificial intelligence and all the stuffs which are nearing us to creating proper agents. But before that, let's try some LLM-related concepts first. So, messages. It was a video on Spring AI already. I think I was talking about that there are different types of messages. We have the system, AI, or human message, tool message. We will check it later. And they're here for different reasons, like system message, we defining the AI agent or AI assistant, the way how it behaves, and then AI message and system message is a human message, and AI message is kind of communication between LLM and human being sitting next to the computer, like I'm doing at the moment. So what we have here, all the communications are happening via messages. So we are writing a message, we create it, it's sent to LLM, we get back the response from LLM. We are adding this message to our list of all the messages, adding something on top and sending again. So this kind of dialogue is happening. And here you see the result or example of that, right? So we have a system message. It says, okay, you're this kind of assistant, you are doing this and that, and this is your goal of existence at all, et cetera, et cetera. And then, well, this was the first message from the AI machine, from LLM, and hi there, I'm your AI assistant, da 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 da, and name model. And then it was another step of communication. The human being wrote, okay, how can I handle all my to-do comments? and the LLM replied something, and then human wrote again something in all this kind of stuff. So this is the way how the communication looks when you're talking to the AI machine to LLM. And well, this is the specific types, the classes we can use in LangGraph, and well, we can try and just pre-print all this communication in one thread. That's good that we have all these messages, right? But at the end of the day, it's not us who are typing these answers. It's the LLM which is responsible for generating it. And for doing that, we can define a chat client. And in my case, this is OpenAI. So if you are going to repeat that on your machine, you have to define OpenAPI key environment variable. You have to set it your own because it's paying for that, for making the calls, right? I define the model, and this is for all mini in my case, and we have messages already defined here. And I can send all these messages, all the conversation to the LLM and see the result. So this is how it looks like. And see, as a result, I have another object of AI message, and AI means this is a response from LLM. So as an input or prompt, I sent as a list of messages to LLM. I got back the completion, which is AI message. And if you're interested what's there inside, it's there inside. It says, okay, we have a content, and this is the raw text we can see in the chat application normally. So it says, absolutely, I'll sprinkle in some SQL, there it does, just remember, and some other stuff you're not interested in, right? And also there are some metadata as well. Like we can see how many tokens were in the prompt, the completion token numbers, some other data like the model name, the real one. Like we can see that this is from July of 2024 and system fingerprint and a lot of different other information which you can call metadata. All right, so far so good, right? It's not something you never know. Probably you knew this already in the past, and it's kind of boring. But let's make things a bit more interesting, and let's talk about tooling. So what's that? I will show you this diagram. And in general, this is the way how you would give the LLM a tool to solve specific type of problems. So here how it works. You have an LLM and you define specific tool. Like for example, here, this tool is a Python multiplying function, which just do the mathematical stuff and gives you back the result. And I'm saying, okay, if you have a feeling that this tool is useful for something, please use it. And that's it. The tool is registered in the scope of LLM, and LLM knows about that. So what happens next? If there is a request that looks like a tool might be useful, for example, what is 2 times 3? And this is about multiplication, probably. Then LLM doesn't answer you in a normal human way, right? Like, I have no idea who is 2, how many cows is 3, etc. But instead, it gives you the structured result, and it would look like this one. So it would tell, okay, for this kind of query or prompt, the response should be applying a tool with the name multiply and arguments a and b, because we have it here, to 2 and 3. And this is how it works. Sounds maybe not so clear, right? But let's check it in this code snippet. So what do we have here? We have multiply values and a and b. We do have doc string, and this is important thing, and we return some value. And then we do have our LLM already, which we defined in previous step, and we are binding tools providing these multiply values as an argument. And as a result, we have an LLM which knows about your tools. And well, maybe another interesting question, like here, having a prompt request, what is 2 times 3? How should I know like that this tool is capable of processing this? And in general, there are a number of factors. It's a huge amount of different data that's been analyzed and saved in the LLM, but you can think in a short way, like what can be analyzed? The name of the function, for example, like multiplying values. It's clear that what it is about, right? We have this doc string comment which gives some or provides some insights like why do we need this function, what it performs, what's the parameters. We have the number of parameters, for example, A and B, 2, and here we can see, okay, we can extract, there are 2 parameters. So all these kind of hints, LM uses them to find the proper tool for processing this request. And this is extremely important because this is already part of AI agents. This is like what agents has, right? Agent have all these different tools, and it's up to the agent, especially if you're talking about autonomous agents, to pick the tool, the right one, and try to perform the job. So it's a very important concept, I would say. And just to demonstrate it to you, okay, let's create LM tools, which is aware of multiply values. And now we have these LM tools we can invoke as a human being asking what is 2 multiplied by 3, and we will see the result. And I hope it will be correct. So see here, what's happening. We do not have any content anymore, so the response is empty. But instead, we have this additional keyargs thing, key, and it has action tool calls, and there is a tool definition. So we have this is a function, the name is multiply values, which is exactly the name of the function we have here. And then it defines arguments A to 2 and B to 3. So this is how it works with the tooling thing. Again, you have to register your tool in scope of the LLM. LLM takes into account a lot of different parameters in order to just understand that for specific queries, it has tools to apply. And then it will not respond to you. It will just give you the information. Okay, here's the tool. Please make a call to this tool, and you get your answer, the one you need. All right. All right, enough plain LLM things here. At this state, we know how to create a LangGraph graph or state machine, and we know how to operate with this tooling and making the calls to LLM and this list of messages. Now it's time to merge these two together and create something a bit more useful. And if you move back to our state machine, then remember we have this state and we are passing the state. And when we are creating LLM application or AI agent, LLM, the information we are passing through all the nodes. Most cases, this is messages. So it's communication between different tools, between user, between previous results, all this together. And all this together, it makes a list of messages. So in general, our state becomes a list of messages, and here we have it already. We define messages state, which contains, as I said, list of messages of any type. But the problem is this approach, like if I'm scrolling back to node 1, 2, 3, the problem is this approach that we are replacing current state, right? And it's not what we want to do, right? Because every single step, every single iteration, it adds some information on top. So we are not interested in overwriting this information. We are interested more in adding this information to the list. And for that, if we are talking LangGraph, wait a second, I have to scroll down. Down, 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 down. If you're talking about LangGraph, then we can reuse so-called reducers. So this is specific modifiers. Well, I'm not going to talk a lot about that, but in general, using these reducers, you can define that your list of messages won't be overwritten all the time, but instead it will be modified in the way you want. And the way you want is adding a new message on the top. So this is how it works. We are still on our messages state, and we have our list of messages, and then we are using this modifier, which is add messages, and this is how it all works. As an example, for instance, we have initial messages as a single system message, and we do have a new message. And then if we try to use this modifier, let's see what's happening. Nothing is happening because I forgot probably to import the previous statement. All right, is there. So at the end, we have a list of 2 messages already. So the second one was added on the top, and that's exactly what we want. And if you are scared of this unknown construction from Python, if you're afraid of making mistakes here, it's very typical use case that your state of your graph is a list of messages. It's so typical, it's so commonly used that even LangGraph comes with specific message state class that performs this already for you. So you don't have to create all this overcomplicated construction, which you can use, by the way, to check someone's level of knowledge of Python, but instead you can just reuse this one. And again, I'm providing this example, and let's try and combine all the things together in a graph and with tooling and see how it works. But this time we will not be using the pure LLM call. Instead, we will try to use LangGraph model and our state machine. Well, probably, it's pretty simple. You saw it already. We define a node, which is a Python function. We have a state, which is a message state, the one from LangGraph this time. And what we are doing, we are making a call to LLM tools, the one we defined earlier. And we are providing all the messages, the whole list, and we're storing that to messages as well. And then again, we define a builder, we add a node with the name LMS tools. We are stating ages, we compiling the graph. Well, we can check again how it looks like. And it's pretty straightforward, right? It's almost like a single LM call, but it's a bit more complicated this time because we have our tooling. But anyway, graph is ready, it's here, and we can invoke it. And for example, we can pretend this is a normal chat application, like ChatGPT. So we would ask something like, hey, how are you? And we will see the graph would work from start through LMS tools and end, and we will see what messages will be collected. So what the communication happened. So I'm running it, and it takes time because now it's real call to LLM. All right, it's okay. And here we have it. The first message was the one from us, how are you? And AI respond to us, I'm just a computer program, so I don't have feeling, but I'm here and there and ready, and etc. All right, nothing special, right? Even if we send this to LLM's tools, the response was pretty normal, like from chat application. But this time, let's try utilize the tools we have. So please multiply 2 and 3 for us. And this will be a new session, so it doesn't have any knowledge about the previous conversations, and we'll see how it works. You now see it's totally different, right? Because on our multiply 2 and 3, we have AI message or response back that, okay, this is a tool call. You need to trigger multiply values, and you have these arguments, so please do it. So this is the way, okay, we have already some artificial intelligence here, right? So based on our request prompt, the LLM responds differently. All right, that was very basic idea of how to construct your graph using LangGraph Studio and API. We created kind of chain already, the state machine. For the next video, please, what to expect. Please expect to we'll try to create a router and maybe a fully autonomous AI agent. So stick with me, wait till the next video, give me a like, and see you next time. Okay.